What's up guys? In the last class we have learned about what is a composite function is, and we have also seen the chain rule of the differentiation, right? So in this video, in this class, we are going to solve the examples related to the exercise 3.1. So let's start with solving the exercise. So I'm going to write here exercise 3.1, and in that you have the first question, right? The first question is given as find dy by dx if this is the first question, and the sub question is y is equals to square root of x plus 1 upon x. Okay, so what this question says that you need to find the derivative of y with respect to x if y is equals to root of square root of x plus 1 upon x, right? So to solve this, if you notice, this is basically, a complex looking function. So it is like the square root of x plus x, right? It's not root of x, but instead it's a root of, x plus 1 upon x. So what you can do is to solve this, you can write to solve this, I'm going to say that let u is equals to x plus 1 upon x, right? So the inside this square root, what I did is I have assumed that let u is equals to x plus 1 upon x. So the y can be written as y is equals to square root of u, right? If you notice, this is y is equals to f of x, and what I did here is I have, substituted the inner square root as u. So this is given as y is equals to f of g of u, right? So basically, the original y was a function of x. I have substituted x with a new variable, right, u, and this whole thing is written as f of g of u. So this is basically a composite function, right? Y is equals to square root of u. So what I'm going to do is I'm going to write differentiating both sides both sides with respect to, with respect to u, we get, right? So why are we differentiating with respect to u? Because y is represented as a function of u. So y is a differentiable function of u. So that's why we are differentiating both sides with respect to x. So when we differentiate both sides with respect to x, it is written as dy by du is equals to d by du of root of u, right? And we know that the derivative of root x is equals to derivative of root x, sorry, is equals to 1 upon 2 root x. So the derivative of root u would be 1 upon 2 root u. So the answer for this is 1 upon 2 square root of u, right? Also also remember that we have substituted the inner x plus 1 upon x as u. So we know that u is equals to x plus 1 upon x. So what we are going to do is we are going to differentiate both sides both sides with respect to x, right? So if you differentiate both sides with respect to x, this is written as du by dx is equals to d by dx of x plus 1 upon x. And if you perform the differentiation, so I'm going to go to the other side, right? And if you perform the differentiation, du by dx is equals to derivative of x, right? Derivative of x is 1 plus derivative of 1 upon x is minus 1 upon x squared, right? So we know that in the second class, we learned that the derivative of y is equals to u plus v is given as dy by dx is equals to du by dx plus dv by dx, right? So we have just performed the derivative, right? So derivative of x is 1 and derivative of 1 upon x is minus 1 upon x. So the du by dx is given as 1 minus 1 upon x squared. By chain rule, by chain rule, we know that dy by dx is equals to dy by du into du by dx. So dy by dx is equals to, we know that dy by du is given as 1 upon 2 root u into du by dx, which is 1 minus 1 upon x squared, right? We know this. And if you substitute the value of u here, if you substitute the value of u here, this can be written as dy by du is equals to 1 upon 2 square root of x plus 1 upon x into 1 minus 1 upon x squared, right? This is quite easy. I have just substituted the value of u here as square root of x plus 1 upon x, right? And if you solve this, dy by dx is given as dy by dx will be given as 1 upon 2, right? 1 upon 2 x plus 1 upon x raised to minus half, right? Minus half into 1 minus 1 upon x squared. So I've written this answer. And how x plus 1 upon x raised to minus half, if you notice, this is 1 by 2 into 1 upon root of x plus 1 upon x. And we know that the root of x is given as x raised to half, x raised to half. So 1 upon root x will be given as 1 upon x raised to half, and if this goes to the numerator, this can be written as x raised to minus half, right? So what I did is I have moved the square root of x plus 1 upon x to the top, to the numerator. So that's why we have 1 upon 2 into x plus 1 upon x raised to minus half. This is minus half into 1 minus 1 upon x squared. So this is your answer to the first question. Let's move to the next question, the second question. So the second question says that y is equals to cube root of a square plus x square. So if you look at this question, it is quite. So what are we going to substitute here as u, right? So let's rewrite this. So y is equals to a square plus x square raised to 1 upon 3. Remember, in the previous um, sum, we have substituted square root of x as x raised to half. So cube root of anything will be written as, you know, a square plus x square raised to 1 by 3. So what I'm going to do here is I'm going to substitute, let u is equals to a square plus x square. So y can be written as u raised to 1 over 3, right? It's going to be same. I'm going to differentiate both sides with respect to u. Then we have dy by du is equals to, remember that this is of the form x raised to n. So I'm going to write d by du of u raised to 1 by 3, and this can be written as 1 over 3 into u raised to 1 by 3 minus 1. And if you solve this, this can be written as 1 over 3 u raised to minus 2 by 3, right? So this is your dy by du. Also we have u is equals to a square plus x square. So you can write differentiating both sides with respect to u, we get with respect to x, sorry, with respect to x, we get du by dx is equals to d by dx of a square plus x square, and this is written as, I'm going to move this at the other side, this is written as, so a square is basically a constant raised to square. It will be a constant. For example, 2 square is 4, so it is a constant, and derivative of constant, we know that it is 0. So this is 0 plus derivative of x square is 2x. So the answer is 2x, right? So this is your du by dx, right? By chain rule, by chain rule, we know that dy by dx is equals to dy by du into du by dx. And we know that dy by du is 1 upon 3 u raised to minus 2 by 3 into du by dx, which is 2x. So this thing can be written as 1 over 3 a square plus x square raised to minus 2 by 3 into 2x, and this can be rewritten as minus, sorry, 2 by 3 into x into a square plus x square raised to minus 2 by 3. So this is your final answer, right? This is very easy. This is your final derivative of y with respect to x. I hope you are understanding. If you have any doubt, you can write, you can post your question on the YouTube comment section. I'll be very happy to address those, right? So let's go through this once again. You have been given as y is equals to a square plus x square. So basically it is read as cube root of a square plus x square. So what I did is I have simplified this in terms of raised to, so a square plus x square raised to 1 by 3. And what I did is I have let u is equals to a square plus x square, which is the inner one, right? And so the y, therefore y is given as u raised to 1 by 3. This is a very important statement when you write, when you solve the question in exam, you need to write differentiating both sides with respect to u. So dy by du is equals to d by du u raised to 1 by 3. This is of the form x raised to n, right? We have seen in the second class. Derivative of x raised to n is given as n into x raised to n minus 1. And if you solve this, you will get 1 by 3 into u raised to minus 2 by 3. Also, we have assumed that u is equals to a square plus x square. So you need to differentiate both sides with respect to x. So du by dx is given as 2x. By chain rule, dy by dx is equals to dy by du into du by dx. So you need to substitute first the dy by du, and then you need to substitute du by dx, and you need to just simplify it and write the final answer. This is very easy, guys. I hope you are not facing any problem. Let's solve the third sub question. So I'm going to write the third sub question as y is equals to 5x cube minus 5x cube minus 4x square minus 8x raised to 9. So this is 8x raised to 9. So you have been given y is equals to 5x cube minus 4x square minus 8x raised to 9. So let's write the answer here. So what I'm going to do is I'm going to type again the question 5x cube minus 4x square minus 8x raised to 9. So I'm going to say that let u is equals to 5x cube minus 4x square minus 8x. So therefore y is given as u raised to 9, right? U raised to 9. So you need to write differentiating both sides with respect to what, u, right? So here we have u, that's why we are differentiating both sides with respect to u. So dy by du is given as d by du into u raised to 9. So this is of the form x raised to n. So n, in this case, n is 9. 9 into u raised to 9 minus 1, which is 8, right? So you have 9 u raised to 8. Also we have u is equals to 5x cube. Sorry, I'm just going to rub this up. You have u is equals to 5x cube minus 4x square minus 8x. So we are going to differentiate both sides with respect to x. So you get du by dx is equals to d by dx of 5x cube minus 4x square minus 8x, right? So this can be written as, let me write it for you, d by dx of 5x cube minus d by dx of 4x square minus d by dx of 8x, right? So this is as du by dx. So let me write on the other side. So du by dx is given as 5 into, right, as 5 is a constant, this will go outside. Then we have d by dx of x cube. So d by dx of x cube is 3 into x square minus similarly 4 into 2x, right? Yx, x raised, so 2 will come here, x raised to 2 minus 1, which is 1, minus derivative of 8x is 8. If you solve this, you get du by dx as 15x squared minus 8x minus 8, right? 4 2s is 8, 5 3s is 15, and we have minus 8. So by chain rule, we have dy by dx is equals to dy by du into du by dx, and this can be written as, we know that dy by du is 9 into u raised to 8 into du by dx is 15x square minus 8x minus 8, and we know that 9 u is basically 5x cube minus 4x square minus 8x into this, right, into 15x square minus 8x minus 8. So this is your answer. This is your basically dy by dx, right? I hope this is very easy, right? dy by dx. So this is your answer. Just understand the pattern. If you see any of this function like square root of, some complex looking x terms, or let's say that the complex x, right? For example, here x raised to, this is basically can be, in a simpler terms, this is x raised to 9, but here x is in a complex form, right? 5x cubed minus 4x squared minus 8x, right? So it's just that you need to substitute u is equals to this, the inner part here, basically inner part, and then you need to rewrite y in terms of u. Then you need to differentiate the both sides with respect to u. So you'll get dy by du. Similarly, for whatever you have substituted, right, the complex looking term in a function, you need to again differentiate that with respect to x, right? So here you need to find du by dx. Here you find dy by du, here, and here you find du by dx. And by chain rule, dy by dx is given as dy by du into du by dx, right? If you find both the derivatives, you need to substitute that and find the final answer. This is quite easy, right? In the next class, we are going to solve more questions related to the complex function, right? So I'll catch you up in the next class. Till then, goodbye and see you.